All right, guys, so let's begin drawing our snake. And the main goal of this section is just to make sure that we see a little square of our snake on screen. And we're also going to understand how game loop works. All right, so you're welcome. So the first thing I want you to understand is that every PICO-8 game follows a simple structure with three main functions. So the first function is a function called init. That's the name of the function. Then the second function is the update. And then we have the third function, which is the draw, right? So init is going to just run once. And when the game starts, it runs once, and it's very good for setting things up like your player initial health, things you need to be in their initial or startup stage. Now, update is going to run 30 times per second. And this is where, we handle things like game logic and movement. Now, draw and update are similar because draw also runs 30 times per second, but this is where we draw things on the screen. So let's create these three functions and let's start building our game. And apart from that, we also have custom functions. To create a function, we start with the function name and then we specify the name of that function. For example, let's do an example. Let's say a function techmood, that's my nickname. And then to end this function, we'll actually use a curly brace and then end. So this is a typical example of a function, and then we have the body of that function. So that's just an example of a typical function, but let's create our basic functions. So let's just call this our snake game, and these double lines, these double lashes are called comments. Our compiler is going to ignore these comments. So let's set things up for drawing our snake. So our function underscore init. This is how it's written because it's a custom function. It has an underscore in front of it. And this is where we're going to do things like initialize our snake. And then we have our function underscore update, which is another built-in function. And this is going to run every frame. So this is where our game logic. Then we'll have our function underscore draw and end. So what I also like to suggest is that you also code along. You cannot be a very great programmer or game developer if you don't code along and follow along while I'm doing this. The only way to get better is to code along. I spent years just looking at code without typing code, and that was a real disadvantage. So with that being said, by the way, so we have these three functions. We have our init, we have our update, we have our draw. If we save and hit Control R to run, I'll just type CLS to clear the screen and hit Control R to run. Nothing happens. If we make a mistake by not closing this function, for example, if I get rid of the end for our init and run, we'll get an error saying unclosed function at line 2, tab 0. So if I go over here and go back and set the end, save and run, if I hit CLS to clear the screen and hit Control R, or if you want to just type run, this will actually run the game. But since we don't have anything happening, we're not going to see any result. So what we want to do is to make sure that we can clear our screen. We're going to draw a rectangle. We're going to store our snake's position in a list of X and Y coordinates, and we're going to multiply our grid into pixels. All right, so let's go ahead and do all of that. So I'll have a custom function here, and I'll call that our init snake. So I'm just going to say function, and I'm going to call that init underscore snake. And this function is going to be responsible for initializing our snake. So I'll just use the mouse wheel to just scroll down a bit. Now, functions can be called from anywhere in your program, so you're not going to be worried about where your function is. And in our init snake, our snake will be a list of segments, and each segment has an X and Y grid position. So let's just say a list of segments with X and Y pause. I'll just write position to make it very clear. So to create a list, let's say snake, like so, is going to be equal to, and with our curly brace, we've created a table in PICO-8. And a table is a very good data structure for storing elements. Now, what we're going to do is to store our starting snake position. So within our snake, let's create another set of curly brace, which is a table within a table to hold our X value, which I'll set to 4. Next is going to be equal to 4. And for our Y is going to be equal to 4 as well. So let's go ahead and save that. If we run, still nothing happens, right? So it means everything is all set up. So, but we need to draw this snake to the screen, and I'll just set this to make this quite readable like that to ensure this is our curly brace. So we need to draw the snake in the screen, and to draw the snake, let's go over here just after our init snake, and let's just say draw snake like so. To draw the snake, let's create a function. So I'm going to create a function called draw underscore snake like so. Now I'm going to use a for loop to loop over through every snake we're going to create, and I'm going to call that segment. So I'm just going to say for segment. This word called segment is actually a custom function. We could call it even cat if we want, or I, but I'll just call it segment because this is what will contain the parts of the snake. So for segment in all of our snake list, so what do we want to do? Now do is a keyword that asks us what we want to do in this for loop. Basically, when we create each snake segment, what do we want to do to each of those snake segments? So what we want to do is to convert, we'll multiply it by the number 8. So each block is an 8 by 8 pixel, right? So let's go ahead and do that. Basically, each of our snake segment will be an 8 by 8 pixel, because if we look at PICO-8 over here, I actually have some stuff here, but if I press the space bar, you can actually see each of these segments for our game world is actually 8 by 8, and we need to convert our game segment to our world segment. All right, so to do that, let's create a rect fill, and in our rect fill, we're going to say our segment dot x. I will multiply that by 8. And then we'll do that for our Y. So we're going to say our segment dot Y, and we'll multiply that by 8 as well, just to convert that into our coordinates. And then for our X and Y movement position, we're going to say segment. I have to spell that properly. If I make one mistake, it's not going to run. So segment dot X multiplied by 8 plus 7 pixels. That's what I found works. And then our segment dot Y multiplied by 8. I'm going to add that to 7. And then our color, we're going to use color 11. Right. So that's basically green. If we go over here and go over the color 11, you can actually see the number green is showing. If we wanted a yellow snake, we can use 10, but I'll just start with the green section. And let's not forget to end our for statement. So here, just after this 11, if I just go back a bit like that, I'll just end this for loop. So I'm just going to say end. And for our snake, our draw snake function, we're going to end that function as well. So we have 2 functions. So now we need to also update the snake. Basically, we're going to update the movement for the snake. So let's create a function. We'll call that update underscore snake. And here I'm just going to say move snake. and I'll just end this and save this. So we're not really done yet. To draw our snake here in our draw function, we first need to clear our screen. So I'll call the CLS or the clear screen function, and then let's call our draw underscore snake method here, right? And in our update, what do we want to do? We want to update our snake in our update function. So here, I'm just going to say update underscore snake like that. And let's not forget our init. In our init function, what we want to do is to initialize the snake. So I'm just going to say init underscore snake. Lots of snake talk here. And if we run, we can actually see a problem here. Attempted to call global update snake a nil value. So let's see what that is. So it does not see, it's supposed to be a P, update snake, save and run. And let's clear the screen. So it's actually good to see these errors and see how we can actually fix that. So it says in draw snake line 32, attempt indexed global segment. Good. So that's a typographical error. That's a syntax error. So it's seg E, like I explained, actually made a mistake there. So let's save and run. So we have another error here. It says attempt to index global segment. So let's see the line where the error is. The spelling is totally off, and that's quite shameful. I don't know my spellings. So I need to pick just one word here. So I call this segment. I think let's just call it SEG, segment, like that. So segment and segment. I think that's correct. That's correct. I think it's better to just spell. All right. So with all the spelling errors out of the way, that actually happens. I don't know why. Maybe I'm a bit nervous, but that's just how it happens. And it's good. I'm actually leaving this in the edit just to show you how it works. So our main update was just to draw a character on the screen, to draw a basic character on the screen, which we've just done. So let's just take a look at the code and see what that does. So let's start with the draw function. So CLS is going to clear the screen frame so we don't see any trails. When we start building these sections of the snake, I'll show you why that's very important. Now our rectfill has an X coordinate, a Y coordinate, and a color. If we go over here and let's clear the screen and say help on rectfill or regular rect, it has an X0, Y0, X1, Y1, and it also has a color to be filled with points at opposite sides. So that's why we are passing that initial value here. Now our snake position is actually stored in a table, right? That's what we have here. And then multiplying it by X will return our grid coordinates into pixels, right? And basically each block in PICO-8 is 8 by 8 pixels. So if we want to know the number of blocks that fit on the screen, like I showed you this tile map, would actually divide 128 by 8, which is 16. So we get 16 by 16 grids. Think about it like a mini chessboard. Now, because we're building a simple game like a snake game, the movement will actually be smoother and with easier detection. And we're also making our game math stay very simple without, any decimals. That's why we're using the snake coordinates in this form or manner. And basically what we're doing is converting our grid to pixel coordinates. So basically here, when we actually multiply the grid coordinates by 8, because its grid cell is 8 pixels wide and tall, we actually get those values to convert it to a square pixel. And all that might be confusing, but basically think about it like you're using X and Y to describe which cell the snake is in, and then we're multiplying that by 8 to tell PICO-8 where on the screen to draw that cell. So basically that's what we're doing. Pixel coordinates converted to grid coordinates. Now in our next lesson, we're going to learn how to move our game character smoothly in one direction. We're actually going to respond to our movement input, and we're going to stop our snake from reversing. So see you guys in the next lesson.